All right, so concept 2 is factoring, and this is something that you have hopefully learned in the past, but if you didn't get it then, or if you've forgotten, or even if you did get it great, this should hopefully be a good review and reminder so that you can do well on it this trimester. So the first type of factoring we actually went over in concept 1, and that's greatest common factor. So I'm looking for a number and or variable that goes in to both of my terms here. So I have a 3x and a 3. So that one's pretty easy. Obviously a 3 goes into both of those. So if I factor out a 3, then 3x divided by 3 is just an x. Negative 3 divided by 3 is a negative 1. So this is factored. So right here where it says factored, I'm going to go ahead and write 3 times x minus 1. But it's not solved. Solved would mean I know what x equals. So this is how I go about solving it once I factored it. You're going to set each of your factors equal to 0. So I'm going to set 3 equal to 0 and x minus 1 equal to 0. Except, does this make any sense? 3 equals 0. There's no x to solve for, and 3 doesn't equal 0, so this is actually not included. But my x minus 1 equal to 0, to get x by itself, I'm going to add 1 to both sides. So then x equals 1. So for the solved section, I'm going to say x is equal to 1. So on number 2, we're going to start the same way. So I need to factor out a greatest common factor. So this is just 1x squared minus 4x. So the only number I could factor out is a 1. But both of them do have an x. So I could factor out an x, and then I'd be left with x minus 4. So this is factored. So factored form is x times x minus 4. In order to solve it, just like I did on this side, I'm going to set each factor equal to 0. So I'm going to set the x equal to 0 and the x minus 4 equal to 0. For the x equal to 0, there's nothing to solve there. It's already has x by itself. But with our x minus 4, I'm going to add 4 to both sides, so that x equals 4. So the solved version is x equals 0 and 4. So that's it for this section. Number 3, this time I can factor out both a number and a variable. So 9 and 6, 3 goes into both of those, and they both have an x. So then I'm left with 9x divided by 3x is 3x. 6x divided by 3x is 2. So I'm again going to set each of these equal to 0. So I'm going to set 3x equal to 0 and 3x plus 2 equal to 0. And this time I've got solving to do on both of them. So this one, to get x by itself, I'm going to divide both sides by 3. So my 3's cancel. And then x equals 0 divided by 3, which is just 0. So x equals 0 as one of its solutions. And my factored form, I should have rewritten it already, is right up there. 3x times 3x plus 2. Then on this one, to get x by itself, I'm going to minus 2 from both sides first. So I have 3x equals negative 2. And then to get x by itself, I'm going to divide both sides by 3. So my 3's cancel. And x equals negative 2/3. So my other solution is negative 2/3. So whenever you have an x squared, you should always have two solutions. This one where I just had one x, I only have one solution. So that can kind of help you gauge if you're doing it correctly. So that's the first type of factoring I want you to be really comfortable with, is just pull out a greatest common factor, set them to 0, and solve. The second type of factoring is when we're given a quadratic where a is equal to 1. And what I mean by a is equal to 1 is there's no number in front of this x squared. So if I start by looking at this one, what we did when we prepped to factor is we would find our a times c. So that would be 1 times 6 is 6, and our b is 5. So I need two numbers that multiply to 6, add to 5. So 1 and 6 doesn't work. 2 and 3, that does work, because 2 times 3 is 6 and 2 plus 3 is 5. So the cool thing about when a is equal to 1 is this is pretty much gives me my answer. When I put this in factored form, it's going to be x plus 2 times x plus 3. And if this were a negative 2, it would be x minus 2. And if it's a negative 3, it would be x minus 3. So you can kind of skip some steps when your a is equal to 1, which comes in really handy. And then to solve it, I solved just how I did the other ones. I set each of these factors to 0. So I set x plus 2 equal to 0, and x plus 3 equal to 0. And then I minus 2 from both sides, minus 3 from both sides. So x equals a negative 2 and a negative 3. So on number 2, you might look at that and say, uh-oh, a is not equal to 1. But the first thing we should think every single time we look at a factoring problem is, can I pull out a greatest common factor? And in this case, I can, right? A number that goes into all 3 of these would be 2. Then I'm left with x squared minus 4x plus 4. So now what I have left in here is an a equals 1 quadratic. So I'm just going to look at this part in parentheses to do my AC, which is 1 times 4, which is 4. My B is a negative 4. So two numbers that multiply to 4 and add to a negative 4. So 1 and 4 don't work. 2 and 2, that's close, because 2 times 2 is 4. 2 plus 2 is 4, but not a negative 4. So in order to make that a negative 4, these would both have to be negative. Negative 2 plus a negative 2 is a negative 4. Negative 2 times a negative 2 is a positive 4. So these two numbers work out. So it's going to factor to x minus 2 times x minus 2. And then to solve, I just set each of those equal to 0. So x minus 2 equal to 0, add 2 to both sides, and x equals 2. And if I were to set this x minus 2 equal to 0, I would obviously get the same thing. So this one has two solutions, kind of, because it has x equals 2 twice. So it still fits with, since I have an x squared, it should have two solutions. But it's not necessary to list the 2 twice. X equals 2 is sufficient. So let's try that same thing one more time. So I have 1 times a negative 14. So my AC is a negative 14. And my B is a negative 5. So two numbers that multiply to negative 14 add to negative 5. So 1 and 14 is not going to get to 5. 2 and 7, that could get to 5. I've just got to figure out what's positive and what's negative. So if this multiplies to a negative 14, one of my numbers has to be negative. And if it adds to a negative 5, it's got to be a negative 7, because negative 7 plus 2 is negative 5. If I did a negative 2 plus 7, that would be a positive 5, and that's not what I want. So remember, when I factor, my signs stay with me. So this was a positive 2 and a negative 7. And then I just set each of those equal to 0 to get my solutions. So on this one, I minus 2 from both sides, and x is a negative 2. Add 7 to both sides, and x is a positive 7. So x equals negative 2 and 7. All right, then the last type of factoring we're going to do is when a is not equal to 1. So this is why we practiced factoring by grouping, because that is how we're going to factor when a is not equal to 1. So in this case, a is 6 and 3 and 6. So we're going to have to use a different method. But we're going to start the exact same way. We're still going to start by seeing if there's a greatest common factor we can pull out. And in this case, there's only a 1, which at this point is not helpful. But when we're grouping, it will be helpful. And then we're going to do our a, c, and b, just like we did on the ones above. So a times c is 6 times a negative 4, which is a negative 24. And b is a negative 5. So I need two numbers that multiply to 24 and add to 5. So 1 and 24 doesn't work. 12 and 2 doesn't work. 3 and 8, that could work. So if I do a negative 3 plus 8 is a positive 5, so that's not what I want. If I do a negative 8 times 3, negative 24, negative 8 plus 3 is a negative 5. So this does work. So now I know that you're going to be tempted at this point to be like x plus 3, x minus 8, like we did above, and be done. That is not the case, which you can obviously see if you try and multiply this back through. X times x is x squared. But this one needs to be a 6x squared. So that's why when I have a not equal to 1, I've got to throw in an extra step. So these two numbers, we're going to use these two numbers to split up this term. And I'll show you what I mean by that. So 6x squared stays. And then instead of writing minus 5x, I'm going to have plus 3x minus 8x, which if I were to add that together, 3x minus 8x is a negative 5x. So I'm not changing the value, I'm just writing it in a new way. And then my minus 4 stays the same. And now this looks exactly like what we did on our factoring prep assignment, and I can just factor by grouping. So I'm going to group these two, group these two. So on this side, 6 and 3, the only number I can pull out of both of those is a 3, and then they both have an x. So I'm left with 6 divided by 3 is 2x, 3x divided by 3x is just 1. And then on this side, remember I never want my x term to be negative, so I'm going to factor out something negative. 8 and 4, 4 goes into both of those, and then I'm left with 2x plus 1, which is exactly what I want to happen because my parentheses are the same. So my 2x plus 1 is my first parenthesis. Took care of that, and then I'm left with 3x minus 4 as my second parenthesis. So this is factor. I'll go ahead and rewrite it where it says factor. So 2x plus 1 times 3x minus 4. That's factored. Done. In order to solve it, I'm going to set each of these equal to 0, just like I did in the two above. So I have 2x plus 1 equals 0. Sorry about that. 3x minus 4 equal to 0. So I start by subtracting 1 from both sides. So 2x equals a negative 1. Divide both sides by 2, and x equals a negative 1/2. I'm going to do that same idea over here. So I'm going to add 4 to both sides. So 3x equals 4. Divide by 3 on both sides, and x equals 4 over 3. So x equals a negative 1/2 and 4/3. So the reason I'm writing it this way is I will often have students who get confused between the difference in solving by factoring and just factoring. So if all it asks you to do is factor, then you're done right here. This is factored. But if it asks you to solve, you take that one extra step by setting them equal to 0. So let's go ahead and try that again. So I start, and I'll do it in a new color so we don't mix up our work. So I start by doing my a times c, which is 3 times a negative 8, which is also a negative 24, and our b is 2. So two numbers that multiply to 24 and add to 2. So 1 and 24 won't add to 2, 2 and 12 won't add to 2, 3 and 8 won't add to 2, 4 and 6 I could maybe get to 2. So one of these has got to be negative, so that multiplies to a negative 24. And if I have a negative 4 plus 6 is a positive 2. So there's my two numbers. Now remember, I can't just immediately put those in parentheses. I've got to use them to split up this term. So I'm going to have 3x squared minus 4x plus 6x minus 8. And then I can factor by grouping. So I'm going to group this side, group this side. So on this side, the only thing I can factor out is just 1x, because 3 and 4, the only thing that goes into that is 1. So I'm left with 3x minus 4. And then I have a 6x and a negative 8. So 6 and 8, I can pull out a 2, and I'm left with 3x minus 4. So my parentheses term is 3x minus 4. So I'm done with that. And then I have an x plus 2. So that's my factor form right there. Now, I will often have students ask me, what if they put these in different order? Like, what if you did plus 6x minus 4x? You should end up with the exact same answer at the end. What will happen is your x plus 2 is what will end up in parentheses, and then you'll have a 3x and a minus 4 right here. So you might have these two things switched, like your x plus 2 first and your 3x minus 4 second. But the process is the exact same, so don't stress about that. It will give you the same answer. So then I'm going to set each of these equal to 0 in order to solve it. So I have 3x minus 4 equal to 0, and x plus 2 equal to 0. So I'm going to add 4 to both sides. So 3x equals 4, divide by 3, and x equals 4/3 is my first answer. This one I can just minus 2 from both sides, and x equals negative 2. So x equals 4/3 and negative 2. And in order to keep this video to less than 15 minutes, I'm going to go ahead and let you do number 9 on your own. So it's the exact same process as 7 and 8. So try and follow along with that process and see if you can solve number 9.